make these parts with traditional manufacturing methods, the cost would have been somewhere around $10,000 and probably 4 to 5 week lead time. We were able to make these parts for about $150, and it took us about a week to get them printed, debound, and centered.
This region's right next to the Allegheny National Forest and the Appalachian Mountains of Pennsylvania. And really what the core manufacturing of this area is the powder metallurgy industry that was bred out of the carbon industry. A lot of small towns inside the Tri-County area, a lot of blue-collar workers that really have a trade that they should be proud of. It's an integral part of the automotive industry and manufacturing in general, all the way from steel production, aerospace, defense industry, medical industries, all leveraged as part of the manufacturing in this area.
Right now we're in APG's sintered metal division. We're back in their secondary operation where we're doing CNC machining. This would be the old machine chuck jaw. It has less geometry capability in it, and also it takes a long time to machine from the shop as we're doing this out of tool steels. We printed a set of chuck jaws for a complex geometry, and it perfectly matches the profile of a part that we need to machine an ID on. So we printed them on the studio system, and right now we're going through tests to compare them versus the traditionally machined components. The benefits of printing is we're able to make a more complex part geometry and also iterate the design more quickly.
Innovation is not a new thing here at APG. We've been a leader in high-temperature sintering for decades.
We service a lot of different industries, mainly automotive. We also work in the small engine, lawn and garden, firearms, the defense, medical, aerospace, and consumer markets. We are a global provider of metal-formed products. We ship conventional powder metal parts all over the world. We ship MIM parts all over the world, and we're getting inquiries from all over the world for 3D metal products. We have that scale and that capability to service the entire world with our technologies.
One of the problems was a lack of labor that we had to give to our CNC department. So one solution to that problem was coming up with a way of using the machine to tighten and loosen the Allen bolts, as well as pick the parts in and out of fixtures. This was all 3D printed on the studio system. You can see the complex geometry, the coring for lightweight, the radiuses, all stuff that would be very difficult in traditional manufacturing methods and very, very costly.
We started looking at all 3D printing technologies. The thing that brought APG to Desktop Metal is the level of investment required for us to explore the technology was much different scale than if we were to go out and buy a DMLS machine.
What we're doing with the studio system is we're manufacturing the end-of-arm tooling for the camshaft assembly. Also, as we're doing design changes to a camshaft, there's some complexity changes that we need to do. The studio system has allowed us to make some of these complexity changes and also inventory the end-of-arm tooling on the shelf so the line's not down at any time. This is the end-of-arm tooling. What we've been able to do is lightweight this by about 30%, so it's easier on the 6-axis robot, and we're also able to add in some geometries that we wouldn't traditionally be able to do with machining. Currently, this is on test, and what we're able to do is test the hardness, test the cycle times, and see how it compares to a machine version of the assembly. Once we're finished with testing, we plan to move this to our production floor to add flexibility to our work center.
Early on, we became partner with Desktop Metal in the studio system. The team here developed a very innovative bridge to production system, which greatly shortened the time from product award to product launch.
90% of our additive use right now is for internal capabilities, helping us get our customers to market faster, helping us keep inventory items on the shelf that are wear items throughout our facility. We're not waiting for the tool shop or an outside supplier to build fixtures, jigs, end-of-arm tooling. We can design it in a day, we can print it in a day, and then it's ready to be deployed to the floor in less than a week. Powder metal industry has been stagnant for some time. There's been some advances, but adding this technology gives us a leg up on our competition, allows us to put another tool in our toolbox.
With 3D printing, one of the cool things is it changes how you think about things. And once you have this flexibility to design any way you want, there's no going back.
Bringing on the studio system from Desktop Metal has allowed our internal engineers to think differently in how they're designing products, how they're designing process flows.
It does help secure the future of APG because this is a manufacturing technology that's extremely flexible. It can be applied across a wide range of technologies, a wide range of customers. The applications are endless and being developed daily. We don't see this technology as a threat. We see this technology as a promising new opportunity.
We're extremely excited to get the production system in-house at Alpha Precision Group. We have a space available. We're excited about building it out and making it ready for the future of manufacturing with the production system.
We're now able to attract different forms of talent to the area that we wouldn't maybe traditionally have. Additive manufacturing and technology, it's a fast-paced environment. So people like myself moving back into this area that might not be attracted to the more traditional manufacturing methods, this is something exciting that we can propel into the future and really leverage a lot of the expertise that we have in this area, and then also bring in new exciting ideas.